Students, in this video, we are going to learn the various properties and specification of inference on testing the difference between two means under heterogeneous population are going to learn. Independent sample t-test. The independent sample t-test is used to compare the means of two separate samples. The two samples are tested under different conditions to determine whether the difference is significant enough to justify the conclusion that the two samples are drawn from the different population or not. Notations. Let us suppose we have two population labeled x1 for the first population and x2 for the second population with their corresponding means mu1 and mu2 and their corresponding variance sigma 1 square and sigma 2 square. Here we draw a sample of size n1 from a population of x1 and another pair of sample of size n2 from population of x2. When the sample is done independently from each population, then the sample means will be independent of each other. Here we are interested in testing the difference between the mean of the first population mu1 and the second population mu2. We will be test the null hypothesis using the given formula such as h0 equal to mu1 minus 2 equal to 0, or we call it as mu1 equal to mu2. The alternative hypothesis given by h1, that is equal to mu1 minus mu2 is not equal to 0, or we given as mu1 minus mu2 is not equal to 0. Here when mu1 is not equal to mu2, we have two situations: either mu1 is greater than mu2 or mu1 is less than mu2. Sampling distribution of the difference between two means. We have two population. First population, we have population size capital N1, sample size small n1, mean is mu1, standard deviation is sigma 1, variance is given by sigma 1 square. Similarly, the second population is given by population size n2, sample size small n2, mean mu2, standard deviation sigma 2 and variance sigma 2 square, which are given for the two population for first and second, which are given in these notations. Now we are going to see what are the various properties involved when using the independent sample t-test. Here the following properties are very important. One have to keep in mind whenever they deal with the two sample independent t-test. Data values must be independent of each other. Data in each group must be obtained from a random sample. Data in each group must be normally distributed always. Data values are to be continuous always. The variance of the two independent groups must be equal to each other for the two samples what we consider. Now we are going to see the heterogeneous. In the case of heterogeneous of variance, we first dispense the t-test for two independent sample that have heterogeneous variance, that is sigma 1 square is not equal to sigma 2 square. If group size is unequal, then the homogeneity of variance is violated and we may opt to go for a new study what we called as an heterogeneous. In this heterogeneity of variance, we do not know the sigma 1 square and sigma 2 square values exactly. So we must assume. So we must make an attempt to test their difference by using our two sample variance s1 square and s2 square. Here s1 square and s2 square are taken as a heterogeneity of variance and the expression is given as t dash as on n1 plus n2 minus 2 degrees of freedom. T dash is given by t dash equal to x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. Behrens-Fisher problem. In 1935, Ronald Fisher introduced the term fiducial inference. To apply it to this problem, Behrens and Fisher proposed to find the probability distribution of t, which is given by t equal to x1 bar minus x bar 2 divided by whole root of s1 square by n1 plus s2 square by n2, where x1 bar and x2 bar are the two sample means, n1 and n2 are the sample numbers, and s1, s2 are the corresponding standard deviations, which given by Behrens-Fisher problem. let us summarize what we have learned so far in this video. In this video, we have discussed about the various properties involved in the two-sample independent t-test, further its specification and the heterogeneity, that is sigma 1 square is not equal to sigma 2 square. Let us conclude here and we meet in the next video. Thank you.